Calculate the following probabilities based on the standard normal distribution. This is just using the calculator as we've seen before. But what we need to do is set sigma to 1 and mu to 0, because we know that the standard normal, which we always denote by z, is a normal 0, 1. And the first one we're going to do is less than 2.1. So I'm going to set my lower up as, let's go many standard deviations away. So I'm going to say negative 100. I'll explain this a little bit in a moment. And then the upper is 2.1 because we're looking at less than 2.1. We need to set sigma up as 1 and mu as 0. And then when I press execute again, I'm going to get 0.9821. So equals 0.9821. Let's just explain what I did there. So this is my standard normal. Should be symmetric, but it doesn't matter, it's just a sketch. And then 2.1 is here. So less than 2.1, I'm looking at all of the area going all the way back to infinity, essentially. But we know that as we go out here, this is an asymptote, the area gets really, really small. So if I just go to something like negative 100, there's virtually no area from there out to infinity. And so, I mean, we know for 3 standard deviations, which would be at negative 3, going negative 3 to 3, we know 99.7% of it is between there. So if we go out to negative 100, that is absolutely fine. There are other ways of doing this, but it's an okay one. All right, let's carry on with the question. We now want to go between 0 and 1.73. So hit execute, we're back to this screen, and I just want to make the lower 0 now, and the upper 1.73. We've maintained the sigma as 1 and the mu as 0. Hit execute again, and we get 0.4582. And then same sort of thing going between 0.5 and 1.2. So back to there, and then we're going to go lower is 0.5, upper is 1.2, and we get 0.1935. Very often we give these to 4 decimal places, and that's just a hangover from when they used to use tables. And then negative 2.46 to negative 1.72. So back to this screen, just make the lower negative 2.46 and make the upper negative 1.72, and there we go, 0.0358.